voltage and current equations for a small section of a line. We have considered an infinitesimal small section of transmission line of length delta x. Here the length of transmission line is infinitesimally small, that is delta x, and the impedance transconductance is G delta x, and so for infinitesimal section of transmission line, resistance is R delta x, inductance is L delta x, capacitance is C delta x, and conductance, transconductance is equal to G delta x. We know that these four parameters are distributed throughout the length of transmission line. We have considered very small sections of length of transmission line, and this is the delta x. We have considered the delta x length of transmission line. Let a sinusoidal voltage of angular frequency omega is applied between AA dash and the current I flow into terminal A. Now the voltage drop is in the series R and L, and the voltage the voltage applied at point A dash is not same as the voltage obtained at point B dash, since there is some loss in the voltage and we encounter this losses in the series element or series R and L. Similarly, some part of the input current, this input current will be passed through the shunt element C and G, and the output current is not equal to input current. There is some loss in the current, and we represented the loss by delta I, and here the loss in the voltage is represented by delta V. Let us the voltage and current at point B dash is I plus delta I, and the voltage at this point is V plus delta V. So we may write delta V is equal to minus R delta x plus j omega L delta x into I. So we can say that the voltage drop is along this series element R and L, and this is given by these equations. Similarly, current drop is along the shunt element, and this is equal to minus G delta X plus J omega C delta X into V. From this equation, equation 1 and equation 2, here the negative sign indicate that the voltage and current at point BB dash are less than their respective values. So from equations 1 and 2 we may write delta V upon delta X, this is equal to minus R plus J omega L into I. Similarly, delta I upon delta X is equal to minus G plus J omega C into V. From these equations, the lump analysis is valid at all frequency if and only if the lump analysis if and only if the length of the transmission line delta x tends to 0, means the length of transmission line is very small, which is tends to 0 or infinitesimally small. So we may write equations 3 and equation 4 like limit delta x tends to 0 sorry, delta V upon delta x is equal to minus R plus J omega L into I, and limit delta x tends to 0, delta I upon delta x, this is equal to di by dx, this is equal to minus G plus J omega C into V. So these equations this dv by dx this dv by dx from equation number 5 and 6, from equation number 5 and 6 we can say that both the equations are the coupled equations, are two coupled first order differential equations. So we have to decouple to find the solutions of the wave. After differentiating equations 5 and 6, after differentiating equations 5, we obtained d2v upon dx square is equal to minus r plus j omega L into di by dx. From equation 6 we may substitute the value of di by dx, so this is equal to r plus j omega L minus g plus j omega c into V. Into V. So this is equal to R plus J omega L G plus J omega C V. Similarly, we may write the second order differential equations in terms of current. Similarly, so we may replace this term, with gamma square. So gamma square is equal to R plus J omega L G plus J omega C, and gamma is equal to alpha plus J beta. This is equal to under root R plus J omega L G plus J omega C. So from these expressions, I can say that the propagation constant of wave depends upon the primary constants R, L, C and G. These are the primary constant. R, L, C and G. These are the primary constant of transmission line and the operating frequency. So the propagation constant and gamma depends upon the primary constants and operating frequency. So equation equations number 7 and 8. Question number 7 and 8. Equation number 7 and 8 are the homogeneous equations with constant coefficient. So we have to find the solutions of this second order differential equations in terms of voltage or current.